straight linear problem, all we're going to do is we're going to solve for x. Solve for x. So the first thing that we need to do with this equation, since we have parentheses, is we need to look inside the parentheses and see if we can work anything out. But since I can't put 5 and x together or x and 4 together, I'm going to distribute. So I distribute here. And 7x was untouched, but 4 and 5 are not, so I do 4 times 5, which gives me 20, and 4 times negative x, which gives me negative 4x, is equal to, and then I work on the other side, 24x, and then I distribute the 3x here, and it has a negative sign with it, so negative 3 times x is negative 3x, but negative 3 times negative 4 gives me a positive 12. So after I'm done with that, I need to look and say, well, what looks the same on each side of the equal sign, and I combine my like terms. Remember, like terms are things that look the same, they have the same variable and the same exponent. So 7x and negative 4x look the same, so when I put those together, I do 7 minus 4, and I get 3. So I have 3x's plus this 20 that I haven't done anything with. And on this side of the equal sign, I have 24x's minus 3x's, so I can combine those, and I'll get 21x, and then I also have this 12 left over. Now, I need to get the variables on one side. And I always like to work with the bigger numbers because I want my x's to stay positive. So I'm going to take away my smaller numbers. So I'm going to take away this 3x so that it goes away. And I do it on both sides for equality. And I'm left with 20 over here. And 21 minus 3 is 18. So I have 18 x's here. And I still have this 12 that I haven't done anything with. Now, since I've moved all my variables over here, I need to move all my numbers to the other side. So I'm going to say move numbers away from variable. So to move it, I do the opposite again. I subtract. Now I'm left with 8 here, and this goes away, and 18x was untouched. So I just bring it on down, and then I solve for x by doing the opposite operation. Well, the operation that's going on with this 18 and the x is multiplication. So I'm going to divide. And I will end up with x here, and then 8 divided by 18 reduces to 4/9. So x is worth 4/9. Number 12 is the same type of problem. I'm going to rewrite it down here so I have more space to write or to work out this problem. So 2 times x plus 3 is equal to x plus 10. Start off with the same process. I can't combine anything in my parentheses, so I'm going to distribute. And I'm going to distribute 2 to the x, which becomes 2x, and 2 to the 3, which becomes 6. So I have 2x plus 6 over here, and I have not done anything with the x plus 10, so I just bring it on down. Now I need to move my variables. This x is smaller than this 2x, so I'm going to get rid of it. So I'm going to subtract, and I'm left with 10 over here. And 2x minus x gives me just x. So I'll end up with x plus this 6 because I have not done anything with it. Now I need to get since I have all the variables on this left side, I need to get the numbers to this right side. So I do the opposite operation of addition, and I subtract 6, and it goes away. I subtract 6 here from 10, and I'm left with 4. And now I have x is equal to 4. Number 13 is a domain and range problem, but it's interpreting a graph. So what I need to do is I need to look specifically at my titles. The titles that I'm talking about are my x-axis and my y-axis. Well, my x-axis represents miles, and my y is cost, or money, And what the question asks, it says, which statement best describes the meaning? Anytime you see this word meaning, you should be describing what exactly this graph is showing here. So the meaning of the y-intercept in this problem. Okay, so my y-intercept is where it crosses the y-axis. So where it crosses the y-axis is right here at 0, 2. At 0, 2, that means that I have traveled 0 miles because my x represents miles, but I have a cost, I have spent $2. So the point is 0, 2, but I haven't driven any miles, so I need to look at the situation. A says 0, 2 means the cab begins with 2 miles. Well, I haven't driven 2 miles, I've driven 0 miles, so it's out. B says the point 0, 2 means that there's an initial fee of $2 for the cab ride from the yellow cab company before any miles are driven. So this one could be it because that's before any miles are driven. So I'm at 0 miles in 2, or in B. C says 0, 2 means that there is a $2 refund. Well, this word refund refers to a negative number, and this 2 is not negative, it is positive. So that can't be it. And it says the point 0, 2 means the cab does not begin charging for the cab ride until 2 miles. If this was the case, then this point would be my x-intercept right here. So the only solution that I have that is correct is B, because there is no miles driven and I have an initial fee, which means I'm spending $2, so it costs me $2. Number 14 says a linear function in two variables is given below. So this function is what is called standard form. So since it's in standard form, what I need to do is I need to figure out what it's asking for. It says, which statement identifies the y-intercept and slope and zeros of the linear function? Well, the other way that I can write a linear function is slope-intercept form, or point-slope form. Both of them will tell me the slope, but only one will tell me the y-intercept. So I'm going to work into slope-intercept form. Let's go 3x minus 4y equals 24. In slope-intercept form, it has to look like y equals mx plus b, which means my y needs to be by itself. So I need to get rid of the x's here. So I'm going to subtract 3x here, and that goes away. And I'm going to do that on both sides since there's an equal sign. And I have negative 4y is equal to negative 3x plus 24. Well, then I have to divide by negative 4 to get the y by itself, and I'm going to do that on both sides. So when I divide negative 4y by negative 4, I end up with y equals, a negative divided by a negative is a positive, so I end up with 3/4 x, and a positive divided by a negative gives me a negative. 24 divided by 4 is 6. So my slope, I can already tell, is the number in front of the x, so that is 3/4. And my y-intercept is negative 6, or 0, negative 6. But the only thing I'm looking for now is my zeros. Well, let's go back to standard form. 3x minus 4y equals 24. I'm going to get rid of that so I don't confuse you. And I know that if I'm talking about the zeros from what we're talking about with quadratics right now, that means that I'm looking for my x-intercept. Well, with all of my x-intercepts, my y value is 0. So where I see a y, I'm just going to plug in 0. So I'm going to do 3x minus 4 times 0 equals 24. Well, 4 times 0 just leaves me with 0, so it goes away, and I have 3x here, and I have 24 there. And then I just solve for my x by dividing by 3. So x equals 8. So the three answers that I need are my slope is 3/4 or my m is 3/4. My y-intercept is 0, -6, and my 0 or my x-intercept is x equals 8. The last question that we're going to look at today is talking about multiple representations. I have a function written in standard, one written in slope-intercept, one in point-slope. I have a graph, and I have a table. And it wants to know the same rate of change. So if rate of change is my m is equal to rise, which is the change in my y's, over my run, which is the change in my x. Well, in slope-intercept form, it's real easy to look at it because this number right here is going to be my m. So my rate of change is 3/5. The rate of change for this, I need to go ahead and find that out. So I need to figure out what I'm working with and where I need to go. So let's solve this into slope-intercept form. I'm going to subtract my 3x on both sides. And now I'm left with 5y because this 3x goes away. And I have a negative 3x plus 15. And then I can divide by 5. So y is equal to negative 3/5 x plus 5 after I reduce. So my rate of change that I'm looking for is negative 3/5. This one does not match it, so 1 is automatically out. Well, 2 is point slope form, so I write that as y minus y1 equals m times x minus x1. So the number on the outside of my parentheses is my slope. Well, the number on the outside of my parentheses is negative 0.6. This is a decimal form of negative 3/5. So this works. So that's good. Now, I need to look at number 3. Well, if slope is rise over run, and I don't rise here, I fall, that means that my slope is actually going to be a negative, but it's going to start here, and it's going to end right here. So I'm going down 1, 2, 3. So it's negative 3, but I only move over twice. So it's negative 3 over 2. So number 3 is out. So 1 and 3 are gone, and we need to look at number 4. Well, change in y means that y2 minus y1. So I'm going to take 2, and I'm going to subtract 5 away. If I find the difference of those, 2 minus 5 gives me negative 3. Then I'm going to take my x's from the same ordered pair, and I'm going to find the difference of those. So I'm going to do negative 10 minus negative 15, and negative 10 minus negative 15 is positive 5. So this is my slope for number 4. Negative 3/5 matches negative 3/5, and this is my answer. So the only two that I have that work are 2 and 4, and that is answer choice A.